In this video, we'll be understanding about what is Chomsky's normal form and steps to convert a context-free grammar to Chomsky's normal form. A context-free grammar is in Chomsky's normal form if the production rules are in the following forms. First rule is a variable should derive exactly two variable symbols, and the second form allowed is a variable deriving exactly one terminal symbol. So now when I say a variable deriving exactly two variable, let's understand how the production rules will look like. Let's say S deriving AB, that is A is one variable here, B is one variable. So S deriving exactly two variable symbols. So this is in CNF form. Or I can have A deriving B, D. A variable A derives exactly two variables. Or I can have a rule like B deriving AD. That is, a variable derives exactly two variables symbol. So such type of rules, I say that the context-free grammar is in CNF. The next form valid is a variable deriving exactly one terminal symbol. So if I have production rules like S deriving A, so this rule is in CNF form. Or I can have A deriving B. This is also in CNF because a variable is deriving exactly one terminal symbol. So if I have the production rules wherein variable derives exactly two variable symbols or a variable derive exactly one terminal symbol, then I say that the grammar is in Chomsky's normal form. Now let's understand how to convert a context-free grammar to Chomsky's normal form. First step is to simplify or reduce a given context-free grammar. We already know that to simplify or reduce a context-free grammar, we have to eliminate null productions, eliminate unit productions, and eliminate useless variables from the grammar. Do watch the previous videos on simplification or reduction of CFG. After CFG is simplified, check whether the production rules are already in CNF. That is, the production rules are either of this form, variable deriving exactly two variable symbols or a variable deriving exactly one terminal symbol. If the grammar is not in CNF, convert the grammar into CNF by creating new variables for substitution such that the new variables that I use are already in CNF. Now let's take some example wherein we try to convert the context-free grammar to CNF. This is a grammar which is already in reduced format, that is, there is no null productions, unit productions or useless variables, right? Now let's check whether this grammar is in CNF. The rule is deriving AB. This rule is already in CNF because the variable derives exactly two variables over here, right? Now the rule B deriving B. This is also in CNF because the variable derives exactly one terminal symbol. Okay. Rule A deriving AB. Now this production rule is not in CNF. I have to convert it into CNF. How to convert? I create new variables for substitution such that the variables that I create are in CNF. So I know that I need exactly two variable symbols. This is a combination of one terminal and one variable, right? But I want two variables over here. So what I do, I use a substitution for A. I create a new variable for substitution, let's say y1, which will derive A, and this y1 I use as substitution, that is A deriving y1b. So this rule over here for A now is in CNF, wherein I have a variable deriving exactly two variables. So my final grammar will have S deriving AB, A deriving y1b, y1 deriving in A, and B deriving terminal B. So all my production rules are in CNF form. Take one more example over here. Now this grammar is already simplified form, wherein there is no null productions, unit productions, or useless variables. Okay, the grammar is already in reduced form. Now we'll check whether the grammar is in CNF. The production rules are in CNF. Checking for S. The production rule of S is not in CNF because it is having more than two variables over here. That is combination of four variables. Production rule A is also not in CNF because it is a combination of terminal and a variable, which is not allowed. B deriving in A, yes, this is in CNF because it derives exactly one terminal. C deriving AD, this is also not in CNF, it is a combination of terminal and variable. Wherein D, production rule D, deriving terminal B, is in CNF because it derives exactly one terminal symbol. Yeah, B deriving A is in CNF, D deriving B rule is also in CNF. Now, production rule S deriving A, B, C, D is not in CNF. It is a combination of four variables. So I have to convert it into a combination of exactly two variables. So I create new variables for substitutions such that the variables that we create are in CNF. So let's say for this variable AB, I create up a new variable. Also for this combination of variables, I create a new variable for substitution. So let's say y1 deriving AB will be a new rule, y2 deriving CD will be another rule, such that if y1 and y2 both are in CNF, that is, it derives exactly two variables. Now I substitute y1 and y2 on S. Now S deriving y1, S deriving y2. So the production rule of S also comes in CNF, that is, it derives exactly two variables. Yes, now moving forward to production rule A deriving B, B. This is not in CNF because I have a combination of a terminal and a variable which is not allowed. So I look up for substitution. So I create a new variable which derives this terminal B. So let's say y3 deriving B. Okay. And substitute this y3 on A deriving y3 B. So that's how I convert production rule of A to CNF form. Next I have production rule C, which derives AD. This is not in CNF. I have to convert it into CNF by creating new variables. So what I do is I I use this terminal A, create a new variable y4 which derives this terminal A and substitute this y4 back in C. So C will derive y4D. Now the production rule of C is also in CNF because it derives exactly two variables. So my final grammar, which is in CNF, will have following production rules, that is S deriving y1, y2, y1 deriving AB, y2 deriving CD, okay, B deriving A, D deriving B, A deriving y3 B, y3 deriving B, also C deriving y4D and y4 deriving A. Thank you for watching this video. In the next video, we'll be taking up a 10-mark question on how to convert CFG to CNF. Please subscribe to the channel to get notified about a new video.